Okay, this is Professor Thompson, and I'm doing another related rates example from section 2.7, and this is example 13, or exercise 13. A plane is flying horizontally at an altitude of 1 mile and a speed of 500 miles per hour, and it passes directly over a radar station. Now find the rate at which the distance from the plane to the station is increasing when the plane is 2 miles away from the station. So, here's a picture to show you what's going on. So, the radar station is that vertical line right here, or at least it's on the base of that line, and that's the 1 mile altitude. So the plane is flying horizontally above that. So the distance from directly above the radar station to the plane, P, the plane is P, that's what I'm calling X, and then the distance from the station to the plane is this diagonal line D, because the distance would be the closest direct straight line from the plane to the radar tower. So that means that the distance here, d squared, we'll say, is x squared plus 1 squared, which is 1. And so that's just from the Pythagorean theorem. And they want to know dd dt when they said the distance from the plane to the tower is 2, so that's d, not x. That's when d is 2. So that's important. And also, they give you that dx dt is 500. But the main thing here, the tricky part of this problem, is you have to realize that the distance is 2, not x. So it's not when the plane went 2 miles in a horizontal line. It's when the plane is 2 miles away, shortest distance, diagonal distance from the radio tower. So I've got my equation, d squared equals x squared plus 1. And it's plus 1, not y squared, because that altitude is a constant in this case. It's not changing. So if I take the derivative with respect to time, I get 2d dd dt equals 2x dx dt. Well, d is given to be 2. dd dt is what I want to know. dx dt is 500. And x, well, if the altitude is always 1 and the distance is 2, then by the Pythagorean theorem, just go back to the original equation at the top here, x is going to be square root of 3. So now to solve for dd dt, I just divide both sides by 4. And I get 250 times the square root of 3 miles per hour, because everything else was in miles and hours. And there's your answer.